We have Logan, who is an application security engineer at OverDrive. He was a developer for a number of years, moved over to application security, and we're going to actually start off by asking a little bit about his journey from development into security, what made him go for development in the first place, and what made him move to security as a field. Because, like when we spoke with Corey, the path is one that, at least to me, is incredibly logical. I look at it and I say, well, of course, going from this field into that field, that makes complete sense, and it gives you greater capabilities maybe than the more standard, more common pathways.
So after I got out of university, I got a job working as a developer at an insurance company. Um, Later on, I shifted to help. I thought that working with the QA team a bit more would be interesting. So what I did there was essentially write the automations that the QA could then use to actually create the automated tests.
Okay,
So stepping back slightly, so one of the big problems with writing automated tests is they actually require some computer programming knowledge to write.
they do.
So what my job was fundamentally was removing that barrier, making it so that you didn't need to know how to do computer programming in order to write these automated tests.
Okay, that. I'm glad that you brought that up. And before I zoom a little more into that, what made you decide that that would be more interesting than what you were doing prior to that?
To be honest, I got a bit sick of the requests being, hey, just change the color of this logo, or move this object around on the page, or implement this new page that was pretty much just a thin client to a database. It was
Yeah,
all very, very simple. Again, like web facing software development. And none of it's not complicated. It's just very much so. Once you have that actual product built, it's all very simple stuff, generally speaking, which is why
right.
doing that design is so critical and why I think a lot of companies have a bad time about things because all of that design work needed to happen 10 years ago.
Right. Yes.
And they've just been accumulating tech debt since then.
Yes. Okay, that's actually Ranu and I were working on a project recently from a company that was founded around 1999. And to exactly what you're talking about, we found a series of absolutely fundamental architectural vulnerabilities that they cannot get around, they cannot fix because of that, what is it, 2 decades of technology debt that they are in, and they're not going to rebuild the system, and all they're going to do is try to finesse and work this into it in a way that won't ultimately will not work well, which goes back to, your architects need to be good at what they do. Yeah. Oh
Yep.
my goodness. It's such a novel concept apparently. But I think that, so I was lucky because I started development 20 years ago professionally, and a lot of software wasn't created then that is now. And you're a newer developer, shall we say, than I am. I'm not calling you young or me old, but you're a newer developer, and your experiences as a result are different because, first and foremost, I wasn't developing front ends. I wasn't doing website stuff. Website stuff back then was HTML. I think PHP just started coming out around when I started in a meaningful way. Java, like I said, was relatively new. Actually, all of the World Wide Web was still very young, and that was something. It's not like today where you'll get a lot of web developers who are doing C sharp, which is an actual programming language. They're doing Java, which is an actual programming language. No, no, no. If you were doing website development back then, it was scripting languages, and so you didn't typically have computer scientists. And I I feel like I would be sad and bored doing that kind of development all day, every day for a lengthy period of time. I don't know that that's true. Most of my experience has been the back end stuff, doing rockets, doing missiles, doing navigations, communication systems, and torpedoes and fighter jet related stuff and things of that nature, which in and of itself is probably more interesting than I guess like I don't know, doing ASP.NET kind of work.
Yep.
But so much work has moved to that thin client in our field as computer scientists. It feels to me like that's not it's not the same experience that I had, and like I would be bored with it. Like I wouldn't find it fun.
And I found like some of it was interesting. Like again, when I first started there, I was put on one of the more front end facing teams, and this is your effectively customer facing software. And by and large, we were just asked to make very minor changes that frankly felt pointless.
Yeah,
Like again, like, as I mentioned, this is just changing the color of an icon, moving it
right,
around, things of that nature, right? And that was boring. Like it was easy, but it was boring.
right.
So again, when I shifted over the QA team, I found it to be a lot more interesting. Again, now I was essentially writing software to manage the collection of 100 or so fully properly licensed VMs that were running
Right.
these automated tests. It was identifying how these tests were failing and preventing them from doing so, essentially making sure that in the event that the software running on the system failed, the system itself would keep on operating and it would recover from whatever error was applied. And I think, yeah, well, I'll come back to that. On the other side, because again, once we'd written that, it was very much so just making it very easy for the testers to write software. So again, when they're doing their automated testing, they're mostly interested in move cursor here, click here,
Right.
click a field, things of that nature. So it was very much so a case of we'd write the code to essentially obfuscate the actual technical stuff. So all they need to do was click on button X or fill text in button Y, stuff like that.
That makes
But
sense.
yeah, like none of it was complicated.
Right.
The second piece was again, we finished that, and we were sort of looking at each other and like, well, okay, we could just sit here and do nothing, but that's going to be really boring. So let's find some other things to do. So we worked with the group that was responsible for deploying the software from test environments into production, and we essentially helped get them organized and working a lot more quickly by writing software that would just automatically do most of their job for them. So it would, deploy the software to, the user test environment, deploy to production. It would allow for easy tracking. It would provide a prioritized order list. Again, all this stuff. Again, most of this was just thin client, but there was enough other stuff to go with it that was interesting, and it was small enough that we could actually see the whole project. It wasn't just a case of, hey, so just change this color. It was, yeah, implement this actual functionality that's going to be useful, which made it a lot more interesting, shall we say?
Right. Right.
Because like it's always nice when you can actually look at a completed project and think, "Hey, yep, we did that. This is actually useful. People are using it."
Yes. And I think a lot of times when people think of computer science, maybe this actually argues against what I was saying, but at least I'm a back end developer. I will admit it. Front end scares me. It doesn't scare me, but it's not something I'm interested in. It bores me. I don't like it. So for me, I don't expect. I always expect to have to work command line, but I know a lot of people really enjoy being able to see their product quickly. And this is one of the benefits of Agile, quickly working, quickly getting used, quickly actually doing something. I know front end people, they get to see their end product in all of its glory much sooner than the back end folks and the middleware folks. But it sounds to me like you're when you moved over, what you moved over into was something that better mixed because it was a new product. It wasn't
Yep, exactly.
maintenance. You know,
Yep,
you
it was
got
that
that.
new product. Yeah, we could do the whole thing. Like, it wasn't just the front end, it was, essentially the full stack. It was setting up the databases. It was loading the data into the databases. It was creating the integrations between the software we're writing and the database. It was getting that software deployed. It was
Right,
debugging it. It was
right.
getting it going.
Right. And
But
that's an experience that
yep,
I don't think a lot of people make it that far in computer science. I think a lot of people start exactly where you were talking about, where they're, doing that maintenance side and they're fixing bugs and it bores them and so they leave. That's at least what it seems like to me.
yeah, absolutely. Like, and yeah, being able to do that full project and getting that broader picture is pretty important. It's also pretty nice as far as getting promotions go,
Right.
because it's very easy to demonstrate the value you're bringing when you're pointing to, I completed this project to solve these problems. It's much harder when all you can really say is, well, I made the button click in a slightly fancier way.
That's true.
But
That's true. And I think if if I were a listener and I were hearing what you were saying, and I were maybe thinking about going in computer science or I were new to it, the big takeaway for me is because this is how the industry does seem to go. It does seem to go when you enter it, you're doing, I'll call it water boy work. And I say water boy work because I'd use another term, but YouTube would probably start censoring me. Water boy work, and it's not as fun and exciting, but it does get better. It gets better.
if it doesn't get better, that's where all the various comments about, well, jump ship, go to a different company, come in,
Yes.
because at the end of the
Yes.
day, if you don't like it where you're at, there are plenty of other places.
Yes. That's you are exactly right. That is spot on. And that also brings us to another two really important things. First and foremost, that you managed to do that internally, right? And
Yep.
then at some point, you decided to move over into security. And that, I believe, is when you did exactly what you're talking about, but externally, uh, which is
Yep.
what you were talking about. But whereas the first time it was internal, the second time it was external. So, what caused you then to go from building this beautiful software to aid QA to moving more security minded and more security bound professionally?
So, like, as I mentioned, when I was writing the software to essentially manage those VMs, it was very much so in the nature of handling the errors that these badly written test cases were producing. Well, as you can probably guess, a lot of those errors were security problems. So as I worked on fixing those, it was one, an excellent way to learn about a lot of different security problems, and two, I've always enjoyed debugging and finding where that problem is and solving it. And security, in a lot of ways, is exactly that.
Yes.
It is finding out where these problems are in your software, and not the easy ones, like, your software doesn't compile. It's your software is running, but it occasionally does something wrong, or this specific set of input causes it to break down.
Right.
And that sort of thing, it's just so much more fun to actually try to identify these more challenging problems. And security lets me do a lot more of that. And well, again, and yeah, so taking that experience, I was able to, in the event of some reorganization and outsourcing at the company, they essentially decided to try outsourcing their QA department.
Uh,
I was not in the list of people that were going to be outsourced, but I decided, you know what? Let's try making this move into security a bit more permanent. So I did just that. I, in fact, found another job. And shortly after there, DaRon also joined the same company. Now, as DaRon probably knows, and is probably much too polite to tell me, I didn't really know a whole lot about security at that point. Like, I knew computer science, I knew development, and I knew some of the theories around computer security. I knew some vulnerability types, but he was the one that really taught me how to do security, and I think he did a pretty good job.
He's a terrible guy. I think he did a bad job. You should find
Yep.
someone else.
Yep. But yeah, and that, like, at least initially at that location, it was pretty amazing. Like, I had the mentor who knew what he was doing. He was teaching. We were doing interesting work. We were doing valuable work. I mean, we
Yes.
were finding issues. We were writing reports. We were helping the dev teams fix those issues. We were working with a variety of groups. Things were moving forward and generally improving. Then, without going into details, let's just say that things went downhill. DaRon left along with the rest of the team, and including myself, and I ended up moving to OverDrive, where I am doing security. It is certainly different from what I was doing at Highland, uh, but it has been interesting. It's been a lot more in the high level, working out how to do things like develop a secure SDLC, which, whenever you hear the phrase SSDLC, don't. Any software development lifecycle needs to be integrating security.
I
Um,
agree. I completely agree. There is
yep,
no such thing. It should not be
yep,
hanging off in its own life cycle. I do not understand why the commercial world has pushed that.
yeah, yeah. Like, it doesn't work
No.
because the developers are never going to look at the security
Yeah.
side of things.
Never.
And at the end of the day, your ultimate job as a security professional is to get the developers to be writing secure code.
Yes.
It isn't to go in and break things. It
Right.
isn't to, manually search through and find vulnerabilities. What your ultimate goal is to create a development team that consistently writes code that doesn't have vulnerabilities. And
Yes.
everything else is basically trying to teach them how to get to that point,
Yes.
trying to help identify where they're not achieving that. And yeah, so at Overdrive, when I started, uh, there was a security program, but it didn't really do security. A lot of it was doing things like answering RFCs, basically the questionnaires that come in from various groups. There was IT and networking security, so again, setting up and managing firewalls, doing security with VMs, things of that nature. But there was no actual application security. So what I've been doing has been trying to set up an actual application security program,
That's good.
which has been a very interesting learning experience. I will also say that politics suck.
They do. They do. You have to learn, and I mean that's definitely at some point we need to do at least a few on that. But it's having to learn how to give the various stakeholders the carrot that they need to drive the cart forward, because it's not going to. eh, That's one of the biggest problems I see with a lot of security programs is they are trying to push it. And it's like, no, no, no. You can't push developers to do things. Developers are belligerent. They have, I mean, they're like a bloodhound or a scent hound, you know? And it's a good thing. It's a very good thing. You put them on the trail of something, and it doesn't matter if that thing attacks them and tries to beat the living stuffing out of them, they will continue to pursue. And security doesn't generally seem to understand that. So instead, they're trying to push these developers and fight the. No, 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 no. That will never work. That
No,
never works.
yeah, it's not a case of just writing out a process or
Mhm.
procedure policy and just shoving it at the developers and saying, "Hey, you guys need to follow that now," because you know what's going to happen there. Either the development leadership is going to work to shut you down,
Mhm.
or they're going to say, "Okay, yep," and your paper is just a dead letter. Like,
Yes.
you can't just tell them to do things. You need to show them why it's important that they do it,
Yes.
how to do it well, and how it derives value. And
Yes.
also how it doesn't interrupt their scheduling, how it can
Yes.
improve the amount of work product they do,
Yes.
and help them produce better code without
Yes.
saying that they're actually writing terrible code currently, because
Yes.
that's also not good.
Right. Calling the look. I'm. So, all right. You're the perfect person to talk with this about because you are a former developer. developers take a lot of pride in the work that they do, a tremendous amount. And what they do generally, uh, obviously some more than others, but generally is beautiful and it's a good job and it's a hard thing to do. It's hard to take a very nebulous problem, turn it into a concrete problem, and then derive a concrete solution that works in a broad case. A broad case meaning you're not just making it for one person. Anyone can create software for one person and a very specific domain. What's much harder is what the majority of developers do. And you cannot walk in there like a bull in a china cabinet and tell them that all their stuff is terrible. This is something I've gone through and I've explained to security professionals many times over the years. If I go in there with 20 findings and demolish the development team, they will never come back to me. They will never come back to security. Hell, they may quit, and I have seen them quit. Or they may just drop the product altogether. What you have done is you didn't just tell them their baby was ugly. You told them their baby was the ugliest baby in the world and they should have, aborted it. And that's the wrong message. Developers, contrary to the stereotype, do have hearts and emotions.
Yep.
you know, you have to work with them, and instead, it's better you you present them at most 12, 13 findings. And I don't mean individual instances, I mean broad, high level findings. And then you work with them, actively work with them on how to do it better. And they will be overjoyed to exactly what you're saying. They will be absolutely overjoyed because developers take a lot of pride in what they do. They take a lot of pride in having written beautiful code. And if you can show them a way to write code that is more gorgeous than what they were writing, more efficient than what they were doing before, by and large, developers will leap at it. Even your disgruntled, been doing it for 30, 40, 50-year developers, they will generally leap on it. I think a lot of security folks do not understand that.
Yeah, like developers they like producing good code. So you're not going in and saying that their code is wrong. You're going in and saying that, hey, can we enhance your code to handle this
Right.
case?
Right.
'Cause, okay, like fundamentally, most security problems are just a case that the developers didn't think of, that they didn't consider while they're doing the work. Not
Exactly.
always, but most of the time it's just something unexpected, and you can discuss it with them, and the developers will usually want to fix it. Uh,
Yes.
If you don't drown them out, if you're not horribly rude to them, all of that. Like, I've never had a problem going to any dev team with specific or even general problems that I can demonstrate that, that that they've always been willing to step in and fix them.
Yes.
Where you end up with the problems is if, say, you are presenting a report with findings that are actively wrong. Like, say you did testing, you thought something was the case, it wasn't, you
Right.
didn't catch it.
Right.
Like, say you did a code review and you thought, oh, hey, they've got SQL injection here. And you didn't actually test that against the actual product. And it turns out that no, that they didn't. That does not go down well. It is a great way to destroy your own reputation and credibility for all time.
Yes.
And yeah, if you're going to developers, especially if you're working internally, you have to be right. You have
Yes.
to have tested it. You have to have verified it. You have to know it's wrong. It can't just be, oh, hey, you're running a version of jQuery that's two versions out of date. It has to be, well, because you're doing this, these other things are possible.
Right.
And then you don't just say, "Hey, update the jQuery version." It's very much so a case of, "Hey, let's work with you." I mean, if we can update the jQuery version, that's the easy way. But the other option here is, well, the reason we need to update it is because of these problems.
Right.
But maybe we're not using these components, or
Right.
maybe we can, apply some other security protections to prevent the security vulnerabilities. Like with jQuery specifically, a lot of the issues that it's faced have been XSS related in
Right.
that it doesn't sanitize things properly.
Right.
Well, if you use your own sanitization or if you can limit the inputs, that's not necessarily a problem. It's that working with the dev teams to produce a solution that works for everybody rather than
Yes.
stepping down and saying, hey, this is the solution to your problem. You must do it.
Yes.
This is yeah, that will not work.
Yes, you're exactly right. And that's one of the things that I've seen a lot of folks who are newer to security or who haven't done development, they don't understand. And this all goes to our job is to work with developers, not work against developers. Now, some people take this too far and they will tell developers that they have no vulnerabilities even when they do. I have seen that, unfortunately, in a few different instances. Those people, what they're doing is absolutely detrimental to the field in the same way. It damages reputations, especially if you get compromised due to something that they said wasn't a problem. But if I overstate an issue, then I will damage my reputation. If I call something out that isn't, then I will damage my reputation. If I don't work with the developers to produce or to help them produce a remediation that works for them, works for the sim, I can't go up to them and say, "Hey, you have to redesign everything." That will never work. Never. If instead I'm working with the developers actively and I'm part of the solution, developers will love you and they will do just about anything you ask. And you will build a reputation such that they will take your word for pretty much anything. If you sit there and were to say to them, hey, this entire application is vulnerable to, I don't know, something silly, some kind of weird injection, they'll just believe you at that point and listen to you about how to resolve it. I say that because what I'm really trying to suggest is if we become a partner in resolving issues, they will see us as a partner in resolving issues. And it's not adversarial. They won't fight us on everything and they won't question us on everything. Now, questioning is good, but it becomes a much more positive relationship, and you'll see a lot less of that back and forth. I mean, you saw it where we were, you had some people, the developers would fight in tooth and nail, and then you had other people who just destroyed relationships with teams, and then I would have to come in and help rebuild that bridge. One individual was removed from a bunch of projects and would have been removed from more because the development teams demanded it. And it's, you have to sit there and be willing to work with them, and you have to have the experience. And this is part of the reason why I say security professionals, application security professionals, need to have experience. It doesn't have to be in development. It could be in QA, for example. QA is also very good at giving a lot of different possible remediations, but they need to have experience and knowledge such that they can go through and I can give a recommendation. I could say, for example, I need you to prevent session hijacking. So the way I want you to do this is you need to fingerprint your clients. And then you need to store that fingerprint and verify the fingerprint every single time you get a client request. Okay, so I had that discussion once with a development team, and the development team said, well, that's great. We definitely understand what you're saying, but this is a stateless system. We're using JWTs. So how can we do this? And I said, okay, so rather than put your fingerprint in a backend database, why don't you put your fingerprint in the JWT and encrypt it? And then, of course, sign that portion of the JWT. And they said, fantastic, we can work with that. This is something we can do. And they went off and they developed. I have seen security folks who do not realize that this is what I call a negotiation. It's a give and take. You pose a problem and potential solution, and then they come back with either acceptance of that potential solution or some kind of rebuttal. And now you work with them to find a meaningful resolution that gives them what they want and what they need to be successful. And it may not be what you originally thought. In fact, it could very well be that you have to diverge immensely. To your point, for the jQuery stuff, maybe the end resolution is they throw in exactly like what you were saying, either a layer 7 firewall that does something, or, and this would be preferable, they throw in something inside of their software where they are now controlling and stripping and managing and encoding, etc., the input to protect this system from jQuery.
So I think one point that is somewhat overlooked, especially in the commercial world, is that at the end of the day, security is usually a cost center.
Yes.
Development, on the other hand, is also a cost center, but they much more directly make money.
Right.
So if you don't get the support of the development teams, and say you start asking them to, again, you don't interact with them, you have your singular solution to the problem, that solution is going to be very expensive and difficult to implement. What do you think is going to happen? The devs are going to either outright ignore you, i- or they may just go over your head and just, cause issues for it, but the
Yes.
problem isn't going to be solved. And oh, by the way, uh, as like at least in my current position, I have zero authority to tell developers what to do. I can't say, hey, you need to fix this vulnerability. It's always the case of, hey, so we found this issue. Can we work together to fix it?
Right.
Yeah, like it's no, like at the end of the day, you have to work with them because they're the ones that do the actual work.
Yeah.
You're just the guy that's sort of poking his head in and saying, "Hey, you're doing it wrong. You need to do it better. Here, this is how you do it better." And you need to make that work. You need to make them go along with it, and you need to make it so that they never realize that they could just say no and go ahead until something horrible goes wrong.
Yes, that's exactly right. You want to make it palatable, and you don't want them telling you to go pound salt. Because whether I'm a third party or I'm part of the company, the end result is just the same. They can very easily escalate up the chain and just cut security out completely.
And it's very easy for them to do so even without escalation because usually like where I'm currently at, we have about 3 people directly involved in application security, and we have, I think it's 70 different development teams doing things. uh, there is no way that we as security professionals can actually keep an eye on what all the developers are
Right.
doing.
Right.
We are relying on them to self-report, so we need to train them how to do that, when to talk with us. We need to make it clear that, hey, that is valuable for them to do, and essentially turn them into our minions to do our job for us.
So I will say, actually, this is maybe a good time to point out. I think one of the biggest issues I have with a lot of these static analysis tools that security folks like to either run or have development teams run is they output, say, 30,000 findings, right? Development teams are going to ignore it for the same reason as if you had a report that had 30,000 findings. It's too much. And oftentimes, those tools have incredibly vague, useless guidance. You can't ask the tool, hey, can you explain this? Hey, can you explain the remediation? Can you explain the guidance that you have? Can you explain the problem? In a lot of cases, you can't even really look the problem up. I saw that a lot of times. Like check marks. I'm not a fan of check marks. It doesn't work well. Having said that, I'm not a fan of any of the static code analysis tools. So maybe the problem is me. I don't
Yeah,
know.
I mean, we've been working to introduce one because of compliance reasons. A lot of security standards tend to require that you
Yes.
run SaaS on your software, or they don't necessarily require SaaS. They require that the software be reviewed by security in some way or another.
Right.
Uh, Security people tend to make pretty good money, which means they are expensive. So actually hiring enough people to do manual reviews of the code that's not a thing, even though that would be a lovely situation to be in as a security professional. But
Job
so you end
security.
up needing SAST, but The problem is it produces such a massive deluge of findings that, well, security doesn't want to deal with it because that's literally all we would be doing every day. But developers don't want to deal with it either because that's also literally what they're going to be doing every day. And the vast majority of it is incredibly low value. Like,
Yes.
again, like we're in the process of rolling it out. And one of the things that we want to do is work with teams to help them burn down their findings. Now, one of the challenges we face is the software that we're using doesn't actually have any way to mark findings as false positives or do any sort of management, which is a pretty critical feature. Um, so what we've been doing has been, we've picked a team. So essentially, we're doing some manual review of the findings, and what we're looking for is some findings that are actually valid. Again, this is a relatively small project because we're picking a small one as a
Right.
test run here,
Yes.
right?
Right.
They have around 3,000 findings. We have gone through around 800 of them. We have found one that was maybe something approaching a problem.
That's how it is. That's
Yep.
that's see, and that's one of the reasons why I sit there and I go, I don't understand why these tools are so bad. Because you've seen the lint tools in action. You saw them
Yep.
when we were at Highland. You've seen them here. You and I have worked together, and these lint tools do a better job finding this stuff than the SAS tools. And all I'm doing is looking for standard bugs.
Yep. Exactly. Like, and they they don't find much of value. They find a lot of little things, and as I mentioned before, you can't just find a problem. You really need to be able to show that it is actually a problem.
Yes.
And that's where I think all of these do, because fundamentally, from what I can tell, all they do is they scan the code, they look for specific functions that are known to have specific
Yes.
behaviors, like, say, they might look for exec or whatever, depending on your language, basically, whatever it is that ends up actually executing given commands.
Yes.
And then they say, hey, you have exec here, this is a problem. If you're lucky, they might note, hey, you're passing user input to this, so it's a problem, rather than just assuming it is one in general. But there's little to no awareness of any sort of sanitization, any sort of limits that might go into it, essentially any possible mitigations that might already be applied,
Yes.
which honestly makes sense. I mean, if you think about it, uh, let's say you have a SQL query that you're just concatenating it and just setting it in, right? Clear SQL injection, right? Well, what if it's not? Because ahead of it, you are fully sanitizing all of the findings.
Yes.
You're fully sanitizing all the parameters and everything. For the SaaS solution, they're not going to find that sanitization. And again, like there are so many ways to do this sanitization and so many ways to do it wrong
Right.
that I'm not sure it's practical for any SaaS solution to actually do that level of analysis. So it ends up being that, yeah, we've got what looks like a pretty clear SQL injection, but it's not actually. And the end outcome is nobody can trust the SAST and it's viewed as a waste of time because
Yes.
fundamentally it is.
Yes. And on top of that, those tools are becoming more and more expensive. So it's a waste of time to run the scans. It's a waste of time to review the reports. And it's in and of itself absolutely ludicrously expensive. And the only reason why people, as far as I can tell, in general are picking it up is because they're required to.
Yep. Like again, like given my preferences, like rather than rolling out SAST, I would much rather set up a internal penetration testing schedule.
Yeah.
Essentially, identify our products, do internal penetration testing on some schedule, try to find problems, do code reviews, all of that stuff. And I think we will find a lot more useful problems
Yes.
and spend a lot less time. And
Yes.
by the way, have a hell of a lot more fun
Yes.
than
Yes.
using the SaaS tools.
Yes, that's exactly right. And that's actually one of the reasons why I don't like there's this division, an artificial one, I would argue, within our industry where they have security engineers and security penetration testers. And I'm going, why are we doing this? Because how can I engineer something when I can't break it? And how can I break it if I can't defend it? And to me, engineers should be more defensive, but they aren't viewed that way. Engineers are viewed as being the guys, and of course, gals, who work with the development teams proactively and all of this other stuff. And then the penetration testers are the ones who slap your hand and say, you're a bad boy. I don't agree with that approach. I think that's the wrong approach. And I think dividing them up as though they're different skill sets is also wrong. But it also means that security engineers get relegated to a footnote in many ways, and they get relegated to doing non-technical work when it's inappropriate.
I am a lot better at finding security problems when reviewing code than I am during an actual penetration test. On the other hand, once I've found that problem, I do have the knowledge and experience necessary to actually exploit it from the penetration test side, which is important because a lot of systems have various protections in place that
Right,
aren't immediately obvious.
right,
And you do not want to go to a dev team saying, hey, can you guys fix this thing? It's a problem, when you haven't actually confirmed it's a problem.
right.
And to do that well, you have to be able to actually do the exploitation. Yeah, sure, you can do a whole lot of cheats. You're working internally. You can actually build the software and
Right,
run it locally. You can put breakpoints in. You can check to see the values.
right,
But at the end of the day, you still need to be able to exploit things.
right.
And if you can't exploit it, or if you can't find out why that exploitation is bad, you're not going to have a good time.
Yes. Yes. And I think really exactly to your point, if you can't exploit it, if you can't do something with this alleged vulnerability from a scanner, from an external penetration team, even from your internal penetration team, then how can you advise people on how to fix it? How can you confirm it's not a false positive? How can you ensure that there aren't false negatives? I, I, I guess I'm at a loss for the division. To me, there it shouldn't exist, and I'm also at a loss for, you see snobbery from penetration testers. At least I do, and I don't think it's warranted. And it's because in the commercial world, I did not have this in the government realm, but in the commercial world, they seem to have this clear delineation. And security engineers almost come off as being more like PMs.
Which, yeah, like I think that really comes down to the knowledge set.
Yeah,
Because security engineers are often delegated to doing essentially non-technical roles, this leads to two things. Either your technical skills atrophy because you're not using them, or the people brought in are non-technical themselves because they're a lot cheaper.
right.
And this ends up being a self-fulfilling
Yep,
prophecy, right?
yep,
Because these people don't have the skills and knowledge necessary to really do their job well, it's often looked down upon. But
yep.
honestly, I see the same problem with the penetration testers. I mean, they often have no idea how to read or write code.
Yes,
Yes, they can run a tool, point it at a website, an application, what have you, and hit the autopone button.
yes,
Okay, that's great, guys, but that is completely useless.
yes,
Like, what you're looking for is a way. You need to be able to explain this problem to developers and how they can go about fixing it. If
yes,
all you can do is find the problem and then apply, oh, hey, Google says that this type of problem is caused by these issues, so we're just going to copy paste that in and go for it. You can't do your job. You have to be able to combine those two, whether that is in one person or a team. But you need to be able to both find those issues and explain how to fix them effectively.
yes. That's exactly right. You are spot on, and that is exactly what I've complained about for a long time. If And this is part of the reason why I say I don't understand how people get into application security when they can't read or write code. This isn't snobbery on my part. I promise. I'm sure there are people who probably just think I'm an elitist or something, and I'm really not. I want as many people to come into this field as want to be in this field. I want as few barriers as possible. But there needs to be, if you come into this field and you don't know how to read and write code, I encourage you to learn. I encourage you to go off, you can take a college class on it, or you could go online. There are a lot of online college classes now that are free, and you could do, I wouldn't do tutorials. Tutorials are terrible. And a lot of the, like the YouTube stuff from the free stuff, this is ironic, but I'm going to say it anyway. The free stuff on YouTube tends also to be terrible. So now that I've said that, you can turn that against me. I'm okay. I can take it. I'm a big boy. But I think, how can I guide development teams if I don't know how to write this code, how their operating system works, how their compiler works? So you remember, I had to work with development teams and explain to them how their software was vulnerable to all of these things, race conditions, memory leaks, and all of this other stuff in very specific constructs. And I sat there and I said to them, well, you've unfortunately assumed that your application is never working on an Itanium processor. And that's simply not the case. Itanium processors have much weaker memory management systems than a Pentium, etc. And as a result, in an Itanium, you now leak memory. In an Itanium, you now have race conditions. In an Itanium, you now have deadlock and starvation. And they were shocked, and they said, well, I'd love to see the instruction language for this, because they'd never heard that before. And I showed them the EMCA and the standards and how it discussed all of this stuff. And it knocked the developers' socks off. It really did, because they had not heard that before. And of course, their software was designed to also operate in Itaniums, and being server software, that actually at the time was a fairly likely thing. And then I got into conversations with the developers further down the road, and they said, well, all of that explains these bugs that we had had for these years, and we could never reproduce them. And this comes down to having a good basis, a good understanding of computer science. And I don't think people have to go that far. I really don't, because I mean, it would be nice, I guess, if we all did, but I think at least being able to read and write code, you don't know if a developer is snowballing you if you can't read and write code. And they will snowball you.
And then to take it another step, if as you are conducting a penetration test, if you can put together the design process that the developers went through in putting together the software, you're going to have a lot better idea of where you're likely to find vulnerabilities, and you'll
Yes.
be able to spend your time more profitably. Because
Yes.
at the end of the day, like, nobody has enough time to test every possible thing that you could mess around
Right.
with whatever application you're testing.
Right.
You have to prioritize, and knowing how that software works on the back end, how it was written, how it's used, can really help when identifying where you're going to see areas that it wasn't written properly, that it
Yes.
wasn't used properly, or that it's not being used in the way it's expected to be used.
Yes. Yes, that's exactly right. That reminds me of a discussion I recently had with another security professional, and I was pointing out to him a number of things. The topic actually was really centered around Port Swigger's, what I will say is very poorly written recent article on race conditions, where they made it was very poorly done. The description was incredibly bad. It was actually wrong in a lot of cases, and then their advertisement of it was complete false advertisement, in my opinion. But I sat there and I discussed and I said, well, race conditions, first of all, computer science understands race conditions. We've understood race conditions for a long time. They have been extraordinarily well studied. We can discuss, okay, well, in these use cases, a volatile, for example, is always going to race. In these conditions, you're locking improperly, you're locking on something that's static in a non-static context, you're doing this, you're doing that. Well, this is going to cause a race condition, this is going to cause starvation, this is going to cause deadlock. I'm locking on an object that is mutable, so someone can now change my object, and now I have a race conditions. Incredibly well understood in computer science, incredibly well detailed and documented. But I said that the truth is, at the end of the day, all race conditions hinge on one thing and one thing only: the developer making assumptions about how and when the application can be interrupted or preempted. It's one is the other. All I have to do as an attacker is understand how I can preempt or interrupt this process. If I understand that, I can execute on any race condition all day, every day. And I do it very easily, very readily on a routine basis. It's not a difficult thing when you can in your mind see, okay, this is what this software is doing. And so understanding that, I know that I have interrupts to do input output. I know that I have interrupts to do this thing, or I understand that this is operating in its own thread. And therefore, taking that understanding, I can exploit this race condition to bypass access controls. I can exploit this race condition to down the system, to do whatever it is I want to do. You just have to understand how that software works. And you and I have walked through where you will take output from an application and you start breaking it down, and you, in your mind, you're building out that code. It's the most useful activity, I think, that you can do. And I've had people comment, actually, I've had a number of people comment and say, oh, well, DaRon seems to be able to tell you exactly what's going on in the back end. So I'm going to go to DaRon because he can explain what's going on. And the only reason why this happens is because as I'm doing what I'm doing, I'm spending the whole time going, okay, so this application is laid out like this. I can tell based on how it's responding, how it's interacting, it's written in this language. I know, oh, look, this response tells me it's a CMS. Okay, understanding the way CMSs work. I know that they're doing dynamic code. I know it's going to sit in a database. I know they're evaling that. All right, so let me grind through how this thing's going to be structured. And that's what's actively going on as I do the test. And it is that way that you can actually exploit things in a meaningful way. And it's also that way that I can give meaningful advice and guidance as to how to fix the problems.
It's also a great way to avoid the piece that I think's often left out when you're discussing red teaming. That is not being really noisy in your attack.
Yes.
If you can precisely target them, then you're going to be a lot less likely to be detected by the various automated security detection programs.
Yes.
Because while SaaS software is kind of terrible, a lot of the endpoint defense stuff, well, yeah, it's not going to catch anything actually novel. If all you're say, or if all you're doing is identify, you're having an automated tool identify everything interactable on the page, you're just stuffing in all the possible inputs and then just spamming the submit button on the page. That's going to be incredibly noisy, very easy to detect. And oh, by the way, you might even be shunted into a higher security setting, which means that attacks that would have worked are now failing.
Yes. Yes. And you won't realize it. And then on top of that, to exactly what you're saying, you also run a greater risk of breaking the system accidentally. It's, for those of you who have done network security for a long time, it's akin to running Nmap with T1, which is very slow, where it's doing the port scan incredibly slowly, versus running it with T5 or Insane, which is just, tons and tons of ports being scanned simultaneously. The noisy approach is going to be picked up in the firewall. The IPS, if they have one, is going to get involved and shut you down and shut you out. All those ports are going to suddenly appear closed. You're going to be on a naughty no-no list and blocked for some time. And you'll see the same thing with the layer 7 firewalls, exactly like what you're saying. That they will do the same thing if they're tar pitting, if they have any denial of service, distributed denial of service protections, anything like that. You're going to kick those off, and you'll find yourself on the bad boy list, put in a corner, and all of your attacks now stop. And it's because you were a fool with the tool. Just to put it as nice as I could, rather than doing a scan to get a lay of the land that just tells you, hey, these are the endpoints, these are the things I can touch, and then trying to tease out the data from those. The big giant, I don't know, burp suite, active scan, audit stuff, just it's not a good plan. And for actual applications versus websites, it's even worse because they're more likely to tar pit you. They're more likely to defend themselves, at least in my experience. Anyway, this has been great. I'd love to have you on again in the future. I'd love to see if we can't talk about some more of this stuff in the future. Actually, one thing I'd really like to do with you in the future is walk through some code, and we can walk together through just a code scan and see what we see, similar to some of the stuff that you and I have done in the past. And I think it would be interesting to have another perspective as we do this, and someone who can offer just that different viewpoint, and maybe hopefully ask questions that I'm simply not answering because I don't
Yep,
think about it
you
or what
already
have you.
know it
Yeah.
because, well, I'm not that familiar with this particular style of code scanning, at least not and having it be useful, which means that hopefully the questions I ask will be useful to other people who
Yes.
don't really know.
Yes. Yes. That would be great. That'd be absolutely phenomenal. Well, thank you so very much. I hope to see you again. Please,
Yep.
if you
So,
like this, make sure you like, comment, subscribe, and we hope to see you next time. Have fun.
yep.